let's use the binomial theorem to expand this given expression, which is the fifth power of 3x squared plus 2y. Okay, again, the original formula says if you have x plus y to the fifth power, it would be just expanded in the form of the sum of x to the k power y to the 5 minus k with the coefficient in front as n choose k, where the index k is the power of x can be taken all the way from 0, 1, 2, and up to 5. Okay, so this would be what we know. But please note that here for x and y, they do not have to be exactly x and y here. Instead, we're going to treat 3x squared here as a quantity. That is going to be our first factor like x in the formula. And the 2y will be our y in the formula. Okay, or you could also view this formula, as a plus b to the fifth is equal to the sum of n choose k, a to the k, b to the 5 minus k, where k runs from 0 to 5. So again, these two terms in the formula are really just some random names. Okay, here we would just take 3x squared as the first term and 2y as the second. Therefore, here's how we solve it. Make sure that each time we treat 3x squared as a quantity together. 3x squared plus 2y to the fifth can be expanded into the sum of the following terms. Of course, I can write that into a sigma notation first, where I sum up the following terms, where n choose k, and again, n here is 5, choose k, and k is the power of the first term inside of my parenthesis, that is 3x squared here. Okay, so I have 3x squared to the power of k times 2y to the power of n minus k, which is 5 minus k. Okay, and k runs from 0 to 5. Let's expand this. For the first term, I have k is equal to 0. Therefore, I have 5 choose 0 times 3x squared to the 0 times 2y to the 5 minus 0, which is the fifth power, plus the second term here, I will have k incremented by 1. Therefore, now I'm going to plug in k as equal to 1. So I have 5 choose 1 times 3x squared. Now I have the power for this as 1. And the remaining power there for 2y would be just 4. Okay? And then we keep incrementing k by 1. Therefore, the next term I will have k as k is equal to 2. So I have 5 choose 2, 3x squared to the square, 2y to the cube. You see the pattern here, so I'm going to do a little quick for the remaining terms. I have 5 choose 3, 3x squared times cube, 2y to a quantity to the square, and 5 choose 4, 3x squared to quantity to the power 4 times 2y quantity to the first plus 5 choose 5 times 3x squared to the power of fifth. Okay, the power of 2y term would be 0, so it's the same value of 1. I'll just omit that 1 there, okay? To simplify this, we will need to calculate some of the numbers and combine some of the terms. For example, 5 choose 0, we could interpret that as just, okay, again, before we move on, the formula for n choose k is n factorial divided by k factorial times n minus k factorial. Okay, so for 5 choose 0, it's going to be 1. Indeed, 5 factorial divided by 0 factorial, which is defined to be 1, times 5 minus 0, which is 5 factorial, so this is 1. Therefore, for the first term, I have 3x squared to the 0th power, this is again just a value 1, times 2y to the 5th. Okay, this was the one we got, right? So 5 choose 0 is 1. So that's also 1. But so the only thing remaining for us to calculate in the first term would be 2 to the 5th times y to the 5th, which is 32y to the 5th. Okay, similarly, we will calculate the value of 5 choose 1, which is 5, times 3x squared to the first, that's just a 3x squared, times 4y quantity to the 4th, that is 2 to the 4th, y to the 4th. And then I have 5 choose 2, which is calculated as, let me erase this down here. For the coefficient 5 choose 2, we have 5 factorial divided by 2 factorial times 3 factorial, which is equal to, if you cancel out the 3 factorial from the 5 factorial, is 5 times 4 divided by 2. So the answer is 10. That is 10, this is 10, okay? 10 times square of 3x squared, which is 9 times x to the 4th, times cube of 2y, that is going to be 8y cubed, because 2 cubed is 8, okay? And then coming here, we have 5 choose 3. The n choose k actually has the symmetric property, which means n choose k is the same value as is of the same value as n choose n minus k. So 5 choose 3 must be of the same value as 5 choose 2. We've calculated that value of 5 choose 2, therefore 5 choose 3 must be of the same. So it's 10 times a cube of 3x squared is 27 times x to the 6th times 2y squared is 4y squared. Okay, 5 choose 4, that will be 5 times the 4th power of 3x squared, that is 3 to the 4th, so 81 times x squared to the 4th, that's x to the 8th, times 2y. Okay, plus the last term here, 5 choose 5, again by symmetry, that's 5 choose 0. We've calculated that number, it is 1. So 5 choose 5 is also 1. Indeed, you might have noted on the two ends of the expanded form, the 5 choose 0 or 5 choose 0, 5 choose 5, or in general n choose 0 or n choose, okay, n choose 0 or n choose n, they're always just ones. It's going to be quite convenient if you memorize these as formulas. Similarly, the n choose 1 or n choose n minus 1, they are the same by the symmetry of the n choose k. That's gonna be of the value n. Okay, these are some quick facts you could refer for convenience when you're calculating these numbers. And then we still have the last part here, 3 to the 5th, that is, I'm going to leave it here as 3 to the 5th, okay, times x to the square to the 5th, that is x to the power of 2 times 5, which is 10. Okay, so this is the expanded result so far we've got, and I'll continue my calculation here. Let me erase that. Okay. All we need to do remaining there is just to combine those numbers and write out our results into a nicer form as the sum of terms look like the number times a power of x times a power of y. So in general, we will have something like number times x to some power times y to some power. Okay. Okay. So let's bring this down. Let's bring this up here. For the first term, I have 32y fifth, and then in the second term, I actually have 5 combined with 3 combined with 2 to the 4th. I'm going to use a calculator to combine these numbers a little quick. 5 times 3 times 2 to the 4th, which is 16. So the answer is 240. And the power of x is squared, is 2. Okay. The power of y is 4. So that's the simplified second term, and then we just keep doing that for every other terms. You may skip this here if you think you got the question, if you think you got the idea, or I will suggest you to pause here and try to perform all the other calculations on your own, and come back to check with me for the answer. And this is the final answer for us to have after we combine all the coefficients in front. Okay? Alright, so do you get the idea here? There will be another example similar to this one posted in the next video clip. Please try that one by yourself first, and then check for the answer if you think you get your own solution.